All right, so today we're going to talk, same thing, trig in the real world, but we're going to learn about angle of elevation and angle of depression. So I have a video within a video to show you. Hopefully this works out. Sorry, that was loud.
SOHCAHTOA, Pythagoras, sine rule and cosine rule, and all things trigonometry actually have a lot of uses in real life, such as working out distances to things, and heights of buildings, and mountains, and navigation at sea. An important part of useful trigonometry are angles of elevation and depression. If you're standing and looking up at an object, the angle from your horizontal line of sight up to the object is the angle of elevation. Whereas, if you're looking down at an object, the angle between your horizontal sight line and the object is known as the angle of depression. Be careful to remember that this is the angle of depression and not this. It's a common mistake to make. We then use all of our trigonometry skills to solve problems involving angles of elevation and angles of depression. Let's look at some examples. Next time you're out and about, stand 10 meters away from a building. Guesstimate the angle of elevation from your sight line to the top of the building. You can now use SOHCAHTOA to work out the actual height of the building. And remember to add on your height to get the correct answer. Here are some questions for you to do. Pause the video, work them out, and click play when you're ready. And so the angle in the triangle is actually 60 degrees. And 1143 meters for the plane. So there we have some real-world uses of trigonometry involving angles of elevation and angles of depression. If you liked the video, give it a thumbs up and don't forget to subscribe. Comment below if you have any questions. Why not check out...
Okay, so there you have it, angles of elevation and depression. So you're going to take notes. I know the boxes are a little small, but you can fit this stuff in. So it says the angle between the horizontal line of sight, so that's the line from your eyeballs. When looking up, we call this an angle of elevation. And the angle of depression, please note, is when looking down. So it's your line of sight when looking down. So again, remember, it's not this angle right here. That's not the angle. It's the one here. That's your angle of depression. So you want to know the altitude and what the angle of elevation or depression is. So you'll usually be given two of the three pieces of information: how far away from the object the viewer is, what the altitude is from the object, and what the angle is between. So your steps are that, so this is the angle here, and this would be the distance from, right? And the other one's the altitude. So you want to draw the picture of the situation, label all the information, and determine, based on the angle and size that you have, label which trig ratio you're using, and then set up and solve your trig ratio. So it's going to be very similar to what we did yesterday, or what we did earlier today. But you're going to see the words angle of elevation in the problem, so I wanted you to be clear on how to set this up. So a hiker is standing 220 feet from the base of the hill, so I'm going to label this 220 feet. The angle of elevation from where he is standing to the top of the hill, right here, is 29 degrees. How tall is the hill? So that's the altitude, that's what you want to hear. And so if we look at this, we know that we have, this is opposite, this is adjacent. We don't have the hypotenuse, so this would be the tangent of 29 equals x over 220. So this would be one where you take tangent 29 times 220. And I'm not going to work the math out because you can type it in your calculator and figure it out. Okay, for number 2, you're going to have to draw a picture. It says a 30-foot ladder forms an angle of 50 degrees with the ground placed against a brick wall. So here's my brick wall. And then I've got this ladder right here. All right, and it says a 30-foot ladder, so this is 30 feet, forms an angle of 50 degrees with the ground. So here's my ground. This is 50 degrees. How far up the wall will the ladder reach? Well, you want to know how far up this wall. So you want to know this height right here. So we know the hypotenuse. Here's my 90-degree angle. We know my hypotenuse. So you're looking at opposite over hypotenuse. So this would be the sine of 50 equals x over 30. And please note your x has to be less than 30. So this is going to be a multiplication problem. Sine of 50 times 30 equals x. And again, I'm not going to work it out. You've got a calculator to do that for you. Please make sure you're in degrees though. Okay, Alex is standing on the ground and he looks up to see a plane. This is the classic airplane. Here's Alex. He's looking up at an airplane. So remember, this is my line of sight. Okay? And he sees a plane. The plane is flying at an altitude of 2 miles along the distance of the ground. Alex is standing on the ground. So here's the ground. Here's the plane. The plane is flying at an altitude of 2 miles. Altitude being the distance, how tall it is, okay? And the distance along the ground is 5 miles. Here's my 90-degree angle. What is the angle of elevation that Alex has to look up? So I guess, because he doesn't give us his height, we're going to just call this the angle of elevation here. So that's what we're looking for. And what we know is we know opposite and adjacent. So it's going to be the tangent of theta equals, opposite is 2 over 5. So again, you're going to have to do tangent -1, 2 over 5. And that should give you the angle of elevation. Okay, Michael, now this is one where I was trying to say, I tried to set this picture up for the previous problem, but they didn't give us the guy's height. So therefore, we're just going to use his feet. But in this situation, we know Michael, whose eyes are 5 feet off the ground. So Michael is 5 feet tall approximately. He's standing 30 feet away from the base of a building. The base of the building is here, so he's 30 feet away. Looking up at a 50-degree angle of elevation to a point at the edge of the building's roof. So you want to know how tall is this building? Well, the first thing we're going to find out is this here, and then we know that this is 5 feet because it matches Michael's height. So we know 30, and we know x, and we know 50. So we don't know the hypotenuse in this case. So this is going to be opposite tangent, again, of 50 equals x over 30. It's a multiplication problem. Tangent of 50 times 30 equals x. And then once you get what x is, you're going to add on 5 feet. And again, I'm not working it out because you have a calculator to do that. Okay. Now I believe you have a paper that's called Angle of Elevation and Depression Worksheet. Here are some more examples. I'm not going to go through these at this time, but if you would like extra help, you may do these problems. But I would like you to do the Angle of Elevation and Depression Worksheet. You are going to turn that in. It is a total of 6 problems that you will be doing in class today and turning in for a grade. All right, your quiz is tomorrow. What's going to be on the quiz? Well, everything we learned this week. Your test will be next week, Thursday. So if you look at the table of contents, discovering trig ratios, how to do SOHCAHTOA. Similar right triangles might be on the quiz tomorrow. Figuring out missing sides and missing angles will be on the quiz tomorrow using SOHCAHTOA. And then trig in real life, there'll be 2 word problems that you'll have to know how to draw and solve for on the quiz tomorrow. All right, good luck. Again, if you want to be successful, make sure you're studying. And then you also have IXLs that you can